Greetings, I'm John the Spirit. I really need to stop AFKing, but I'm almost done with this project, and welcome to new Omnifactory Supershorts. I have all the thermal elemental matter I need, much more than it, in fact. We're going to be smelting up a total of 624 of these blends. That's 432 Lumium blends and 192 Signalum blends, which means we need 624 mana dust, and I've done some calculations and determined that we need 78 blitz rods, 78 blizz rods, 78 basalts rods, and 78 blaze rods. That's 10 matter each dedicated to each type of rod. This is unfortunately a slow macerating process, but I bet I can shove this into my ore processing system to speed it up. I also need 156 of sulfur, saltpeter, snowballs, and obsidian dust. 3 of these resources I can just get from loot fabricating. I'll need 10 matter for the saltpeter, 10 for obsidian, and 3 for snow. 312 verothium dust coming up, 312 petrothium dust, 312 cryothium dust, 156 diamond dust, 312 pyrothium dust, all arranged neatly in this chest absolutely full of stuff for Lumium and Signalum. We'll just take them out set by set and make our mana dust. It's a bit of a slow crafting process. This is about 16 more than 624 mana dust. Now for 432 Lumium blend. I've got all the tin alloy dust right here, along with the energized clathrate and the luminescence. Energized clathrate requires quartz and 2 glowstone. Here's the materials for the 225 sterling silver. Without further ado, here's 4 stacks of Lumium blend, and the rest of it. For our 3 stacks of Signalum blend, or 192, we've got our 3 stacks of anneal copper here, and our 1.5 stacks of red alloy dust, and our destabilized clathrate. We also need 96 ardite, which require 24 blaze powder, and 72 red steel dust, which require 9 sterling dust, 9 bismuth bronze dust, which is made with these resources. By the way, bismuth you can get from cassiterite. You'll also need steel dust and black steel dust. Luckily I already have lots of black steel dust. 72 red steel dust. We must do the ardite in a mixer for some reason. Also, if you're curious how much aluminium and energetic blend I needed to make the luminescence, I needed 54 of each and 108 phosphoric acid, which took 36 apatite dust. Luckily I had a lot of that. Behold, 3 stacks of Signalum blend. Although it will take me an excessive quantity of vibrant alloy cables, I'm going to extend this vibrant alloy cable line so that I can run my tungsten steel with this 1 CEF HV. Actually, I apparently can use end steel cables as opposed to vibrant alloy and save a lot of resources, so I'm just going to do that. Remember, you'll need that styrene butadiene rubber to coat end steel cables. This is where my tungsten steel blast furnaces will go. 2 blast furnace controllers, a bunch of heat-proof machine casings, you never know how many you'll need. We'll put our 4 energy input hatches here. Output buses automatically export to chests in front of them, so my 2 output buses here will automatically output to the chests I have for Signalum and Lumium. 2 blast furnace controllers, and then the heat-proof machine casings. 2 layers of tungsten steel coil blocks. 2 MV fluid input hatches, 1 and 2 MV fluid extractors, conveyors on top of the fluid extractors that I'll set with a screwdriver to import from chests above them so they pull the mana dust, conveyors on the input buses as well with the same settings, and finally the heat-proof machine casings to make our tungsten steel blast furnaces a reality. Amazing! We'll make sure to power the fluid extractors, and now we'll shove our 3 stacks of Signalum blend and mana dust into the appropriate chests. 3 into this input chest, and then the 3 mana dust into this input chest, and hopefully this has started running. Yes it has, very slowly. We're overclocking this twice, so it'll take about 81 seconds per craft, and since we're doing 192 of them, it'll take us 4.3 hours. This immense amount of Lumium is going to take even longer. The reason I've split this up is that I only have a precise amount of each of the mana dust, and so I want to split it up correctly between the 2 fluid extractors rather than letting a bunch of extra mana dust I don't really have access to going into my fluid input hatch and being unable to be retrieved. Lumium takes 91 seconds when overclocked twice, and since we need to smelt 432 of it, it's going to take us about 11 hours. Bad news, we are now using the entire power output of our base. We will fix this promptly by shoving our 38 numismatic dynamos into the world even without the Signalum upgrades and running them. 38 numismatic dynamos later, and now 38 laboratory calibration upgrades, and 38 harden upgrades, and 38 reinforce upgrades, and 38 times 5 fuel catalyzers. They have all been installed. Things seem to have calmed down slightly, so we'll have time to set up our proper DML setup. To handle the ender pearl output of 10 enderman models, we're going to need 1 MV pearl extractor, 3 MV quartz electrolyzers, 4.18 MV chem reactors for resonant clathrate, which is going to be 5 chem reactors, And I believe 5.125 alloy smelters, it might be 6. I might also be wrong. We need to supply 4.784 glass per second. To change this multi-smelter, all we need to do is keep it MV and switch the coils to Kanthal to smelt 5 items per second. You can also do this with nichrome, but I already have Kanthal coils, so I might as well use them. Nichrome is cheaper. To supply the requisite sand, I can either use 2 MV macerators for sand and gravel, or 1 HV macerator for each. The extra 1.196 clay per second, which requires 1.196 dust per second, I'm just going to source from my cobbleworks. This 4 times MBCEF will power the macerators, and we'll source all these other machines from what we already have down here. We'll start by replacing the Kanthal coils, and then to be honest, we're just going to tear everything down because I really don't know what to do with this unless I tear everything down, so be right back. I'm going to be stacking DML chambers on top of each other, which means I'm probably going to be sharing conduit lines. So at this point, I'm going to link up the isolated conduit line that's isolated from the main bus, and which is going to be hooked up to the DML system. And that main conduit line distributing pulsating polymer clay and all the other stuff here is also going to be connected to this line that's shoving stuff into the drawer controller. To that end, I'm going to change all of these to be extracting on brown. Unfortunately, I can't use the conduit probe here. You have to actually be able to look at the little black spot that connects the conduit to the machine to be able to use the conduit probe. I'll stack up my machine tower right here. I'll set the 6 limited item filters to clay and pulsating dust. I'll constantly supply clay to the network. Pulsating dust is already getting extracted down here. I'll set up my 5 chemical reactors, 1 here and the other 4 here, so I can slap the advanced fluid extractor right here between them. I've set these 5 item filters to nether quartz, and I'll filter each of the chemical reactors. Then I'll place this fluid extractor here and filter in ender pearls, and then run ender fluid conduits out of this fluid extractor into the advanced chemical reactors. Because these fluids aren't connected to the main network, I don't even need to use fluids filters, I'm just going to use channels instead. I'm a little worried about round robin, so I'm going to use the molten ender I already have and fill several of these chemical reactors with it. I'll set my last 3 filters for glass. And with round robin on, glass is going into all the electrolyzers, which I'll extract always active from. And I'm going to install some extract speed upgrades on this pipe because it's not pulling out sand nearly fast enough for this system to be able to take everything it needs. However, my calculations do indicate that we have sufficient molten ender exiting this fluid extractor. The real test will be to set all of these to extract always active and hope that the fluid extractor can keep up with all my chemical reactors. Because I'm out of filters, I'm going to use the lime channel for reeds and then insert into this diamond furnace with the reeds in the same channel. I'll place down this 4 times MBCF here with a 4 times energetic alloy cable and slap my macerators around it in a circle. I'll set 2 filters for cobblestone on 2 of the macerators. Yes, I made new item filters, and I'm putting gravel into these 2. Sue me, it's hard to move my mouse and talk at the same time sometimes. These will get extracts always active so that they shove their sand into the input bus like it belongs, although apparently I already have sand going in, but I'm going to remove that now, because this is already supposed to be sufficient for the system, and I don't want to remove from my cobbleworks, which is supplying the rest of my base. And now, because I have 43 blank data models here, 37 of which will be shulker and 6 of which will be enderman, I will set 43 item filters to be pulsating polymer clay. Here's the material for 44 simulation chambers, although I only need 43 of them right now. To save on filters, I've actually caused pulsating polymer clay to extract always active on blue and to insert on blue into all of these simulation chambers. My calculations indicate that to support all these dynamos, 48 of them, Signalum, 12,500 RF per tick, and fully stocked with fuel catalyzers, I'll need 36.36 self-aware shulker data models. I already have 4 down here, so I only need to do 33 more. Unfortunately, these do not stack. I've got all my shulker models set up. Last thing to do is to add the 6 enderman models in order to be able to support this system. One problem, these enderman data models will not be able to support this entire system until they're self-aware, but all these models will be running. However, this 2048 pristine enderman matter should provide me with 49,152 pulsating polymer clay, which gives me 1,260 pulsating polymer clay for each of these simulation chambers. I'm ignoring these ones on the bottom because they're already supported by the enderman models that exist here. And hopefully by the time we have put in 1,260 pulsating polymer clay, these enderman models will be almost enough to keep supporting the system. I have heard on the Discord that it won't take any more than 1,260 simulations, but I don't know because I don't have the numbers in front of me right now, but I'm just hoping beyond hope that this will work. And by tomorrow morning, because I'm AFKing yet again, we should have a bunch of self-aware models and all of the Signalum to create 48 Signalum numismatic dynamos and support them. With that said, see you in 8 hours or so, or however long it takes me to get all this Lumium. One piece of potentially accurate information before we go. If you add up the numbers from JI together, you get that it takes 800 iterations to train it up to self-aware, I believe. Thanks to the Omnifactory Discord, as for basically everything else in this series. Wait, one more bottleneck I hadn't anticipated. The pristine enderman matter might fill up, and then these will no longer be tearing up. Actually, that's not a problem. If my pristine enderman matter is full, then I have enough ender pearls to supply the system, so I don't need to worry about these clogging up. Several hours later, all my models are self-aware, and I've got my Lumium and Signalum. As I suspected, this loop fabricator is not fast enough to process all of the shulker matter. I am experiencing some extra FPS lag from adding all these simulation chambers. One solution might involve slapping chests on each of these lines, putting the pulsating polymer clay from these fluid extractors into the chest, and then extracting from the chest into the simulation chambers. But that's probably not going to work. Another solution might be compact machines. We'll see if I end up needing to use compact machines for DML. Hopefully not, but if I do, I will let you know. We'll install them on and we'll go through it. One extra loop fabricator, filtered on pristine shulker matter, which combined with the first loop fabricator should hopefully be able to handle the output of all these shulker data models. In other news, those 8 hours I were asleep actually resulted in a lot of extra diamonds, and we're up and up on the way to 800,000 diamonds, which is what we'll need for endgame toward the tank. Now, before we turn our Signalum and Lumium into the requisite Signalum upgrades, we're going to need to get those restonia gears, which I'm not going to use the atomic reconstructor for, but the gearworking die from thermal expansion. For that, we need access to mana-infused ingots. We're going to need 16 total for this project, and I have 16 mana dust, but this mana-infused metal dust requires mana dust as well, so we'll need 8 more. I'm making the 4 types of dust equivalent to 40 rods of each type. Here's 4 stacks of mana dust, and 1 more. 8 titanium dust, 16 mana-infused metal dust, 16 mana dust worth of primal mana, and in short order, 16 mana-infused metal. Scratch that, reverse it. I also need a compactor to make these mana-infused plates, so here goes another 8 of these. Excuse me, that was patently incorrect. Apparently, in making the gearworking die, I was already planning for the compactor, but I'm sure I could use this mana-infused metal for any number of other useful things, so oh well. 1 thermal device casing, 1 machine frame, and a compactor, into which we shall place 4 mana-infused ingots and weight, and then make a diamond gear for the gearworking die, and boom, a gearworking die. 1 hardened upgrade kit, and a reinforced upgrade kit, and the 2 kits and the gearworking die. We will set this top side to input and output mode, and turn on auto input and auto output, so that all these restonia crystals will get pulled into the compactor will make them into gears, and throw the gears back up into the chest. Hopefully it's smart enough to not pull in any restonia gears, but it shouldn't, because usually this compactor slot will be filled with the restonia crystals, so the only thing that can be added to it is more restonia crystals. We need to turn 768 restonia crystals into 192 restonia gears for our 48 Signalum upgrades. We'll also now compress our Signalum into its plate form, and make all of our Lumium blocks. Exactly enough for 48 of them. And here are my 3 stacks of restonia gears. And without further ado, everyone, 48 Signalum upgrade kits. Now to upgrade everyone to Signalum. I'll add more of these conduits as I need more of my power. But it would be nice until then to be stocking up on these diamonds. What are my next plans? Eventually I need to fully automate Lumium and Signalum and tungsten steel and tungsten carbide. And I want to mostly automate quantum circuits and nanocircuits as soon as possible. I'll probably get to nanocircuits in the next episode. And I'll also need to set up cryogenic distillation towers in order to get argon, which I'll need for future micro miners. Let's tentatively assume nanocircuits are my next project. But for now, that's it for today's episode. As always, if you have any feedback, I'd love to hear it. I hope you enjoyed, and God bless you all.